Hi, everyone. This time we're going to talk a little bit about some famous telescopes. Now, there are collections of famous telescopes at famous observatories, and these are located at different places around the globe by different countries. One of the things that I want you to understand is where do countries choose to place these? Well, we want to get them away from the air. Our atmosphere is fabulous and we need it to breathe, but it is challenging to look through. It causes interference. So all of the great observatories are going to be very, very high, really, really high altitudes. So up in the mountains, because we want to be as close to the top of the atmosphere as we physically can be. They're typically going to be in dry locations, so desert locations, a long way away from, you're not going to find them in a tropical rainforest, let's put it that way. So high desert is the place that you're going to find lots of telescopes. Remote. Light pollution is the enemy. There have been some telescopes that were put up 50, 60, 100 years ago, and the cities have moved in around them. Well, those are not popular telescope locations anymore. So out in remote areas is best, and then close to the equator. So instead of being in northern climates, unless you're really only looking to the northern sky, if you're on the equator of the Earth, then you're able to see the northern sky and the southern sky. So that's the things and the locations of some of these great, great telescope observatories. Now, in the world of telescopes, these are the rock stars. These are sort of like Madonna and Beyonce and Adele. You say one word or just say their name and people go, ah, these are the important people. The same thing happens to telescopes. So we're going to talk about some of the important ones here. There are lots of them, and so I just want you to be familiar with some of the biggies. One of the most important ones is in Maui, Hawaii, and it's the Keck Observatory. I happen to have been to Keck at one point in my life, and it contains the 10-meter Keck Observatory, which is the whole mountain contains multiple telescopes. The Subaru telescope, there are twin telescopes, there are a variety of telescopes up there, but this happens to be high on a mountain in Hawaii. It's a high desert situation, and it's there because there's low pollution, there's low light interference, and it's a really great place to have a telescope. This is Haleakala in Maui. This is the mountain where all of this is located. And here are some of these. Here is Subaru, the Kecks, the Gemini North and South, that happens to be twins, the Gemini twin telescopes. Different organizations own and operate these telescopes. So Caltech, the Smithsonian has some telescopes up here. One location, because it's so fabulous, it can, even though it's in the United States, other countries like the United Kingdom, Canada, France might actually use that same location for some of their telescopes. This is a view of the night sky from Hawaii, and you get to see the beautiful, beautiful Milky Way there and all of the beautiful, beautiful stars. A much clearer image than we're going to get lower down in the atmosphere. Some of the other images taken by the beautiful big 10-meter Keck telescope, pictures of Jupiter, the distant dwarf galaxy, and some galaxy clusters. Now, considering these are ground-based telescopes, these are amazing pictures with amazing clarity. Hubble. Hubble, of course, is the famous space-based telescope that was launched back in 1990. And when Hubble was launched over 30 years ago now, it was the first time we could get up and above the Earth's atmosphere and the weather and the smoke and the dust and just the heat variations in the air that caused all sorts of imperfections in images. And because of that, we could get some of the most iconic and beautiful images known to astronomy. This is the Eagles. Part of the Eagles Nebula is the Pillars of Creation. Spiral Galaxy, this one has been known through time as the Eskimo Nebula. the Galilean moons of Jupiter. I want you to have an understanding of how big the Hubble Space Telescope is. It's about the size of a school bus. This is no backyard small telescope. This is a very, very large thing. Now, Hubble, because it has been over 30 years that it has been in use, it has had multiple maintenance missions where astronauts have gone up in the space shuttle and have replaced parts and upgraded cameras and fixed some challenges with some of the optics. But the decision was made a couple of years back to no longer send maintenance missions up to Hubble. And the reason is we're dealing with 30-year-old technology. And so our dear Hubble is still working at the time I'm making this video. I hope it lasts for a very long time, but parts do wear out on any mechanical device, and its successor is being worked on. And at the time I'm making this video, it has not launched yet. Its launch has been delayed numerous times. The current launch date is 2021. But I'm not holding my breath on that because that launch date has been pushed back many years through the time that I've been teaching astronomy. So the new telescope, the big dog in town, is going to be the James Webb Space Telescope. Hubble was 2.4 meters in diameter, its primary objective mirror. The James Webb mirror is going to be 6.5 meters in diameter. James Webb is designed to be really maximized for the infrared part of the spectrum. Hubble did the visible plus the infrared and some of the ultraviolet. Well, James Webb is going to go further into the infrared part of the spectrum. Why? We want to know what has occurred deeper in space, distant in the past, and that means we need to look at those longer wavelength lights. That means we needed a bigger dish in space that is protected from heat. The James Webb Telescope, once it gets deployed, is going to have these solar shields that will help protect it from the sun. So it is an amazing piece of engineering because it is going to have to be folded up into a little tube when it gets launched into space. And then once it gets launched, it is going to have to fold out like a piece of origami because the mirrors have to fold out to this flat configuration. This whole sun shield is going to have to fold out like a butterfly unfolding its wings. And if you're taking this online, please watch these little short minute animations of the deployment and the unfolding of the James Webb Telescope. It's an amazing, amazing piece of engineering. And the question has gotten asked very often, why does it keep getting delayed? Well, it keeps getting delayed because this telescope is going to be approximately, not quite 1 million miles away. And you cannot send a repair mission that far to fix it if something goes wrong. And it's a very complicated piece of engineering. Now, because the James Webb Space Telescope is going to be primarily looking at the infrared part of the spectrum, and infrared is heat. Well, what gives off a massive amount of heat? Well, the Earth does, and the sun does. And so we have to protect this telescope from us. This is an infrared photo of the Earth, and this is an infrared photo of the sun. We produce massive amounts of heat in the electromagnetic spectrum. So once this telescope gets up in space, this heat shield is going to be deployed, and it will spend its entire life with its back to us. So on the back that will be to us, there are going to be solar panels that are going to power it. There are going to be antenna so that it can send radio signals, pictures, and data back to the Earth. There are going to be onboard computers, and there are going to be jets and wheels that will help steer it to make sure that we can keep it on course. This is going to be all aimed towards the Earth and the sun. And this is also going to be the hot part, 185 degrees Fahrenheit. The cold side is going to be faced towards space. And what it's going to be looking for is it's going to be looking for infrared radiation coming from distant stars, exoplanets, and the outer recesses, I can say that word, of the universe. Now, where is it going to live its life, it's going to live its life at something which is called the Lagrange point. The Lagrange point, abbreviated as the L2 point, is a mathematical point that if you draw a straight line from the sun to the earth to this point, which is called the L2 point, this is the point where if you put something in orbit, it will keep it in a synchronous orbit, so it is always with the Earth as we orbit around the sun. As we orbit around the sun, the James Webb telescope will come with us, but it is not going to come with us in a nice straight path. It's actually going to be orbiting in little circles on this path. Again, I'm going to have a video that I'm going to ask you to watch, a little 20-second video that's going to show you the orbit of James Webb. And it's kind of wacky, but it works, and it's so cool. Actually, it is going to be orbiting the sun more than it is orbiting the Earth, and that's how the math is going to work out. So this telescope is going to be 930,000 miles away, a little under 1 million miles from the Earth. To put it in perspective, it is about 5 times further away than the moon is. So that is going to be a long way away. As I said, that means we are not going to be able to send anybody up to fix it if anything goes awry. All right, I'm going to ask you to watch a couple of videos about James Webb, and when we come back, we're going to talk about some more important telescopes. We'll see you then.